Welcome back to this video lecture series on data structure and algorithms. So today we will be knowing about the famous traveling salesman problem. So first let's have a look at the problem statement. So it says that from a given set of n cities and distance between each pair of these cities, find the minimum path length in such a way that it covers each and every city exactly once without repetition of any path, and terminate the traversal at the starting point or the starting city from where the traversal of the traveling salesman programming algorithm was initiated. So basically, if we try to take up an example, let's say this is a graph we have, and let's consider all of these nodes 1, 2, 3 and 4 as cities. Now if a salesman starts his journey from city 1, then we need to find a path through which if he travels, then he will cover all these cities, that is 1, 3, 2 and 4, and then again will come back to 1, so that the cost for traveling is minimum. Now in this adjacency matrix, you can see the cost for one node to another is given. So we need to find the minimum cost path so that the salesman can start from a city, travel all cities and again come back to that same city. So let's have a look at the strategy that we'll be taking on. So we will be maintaining two variables, a cost variable and an array, a visited array. So the cost variable will help us to keep track of the updated minimum cost, and the visited array will help us to keep a track whether a node is already visited or not. What we will do, we will start with a source vertex or a source node, the starting city basically. We will mark it visited and we will look for the next neighbor node with minimum cost. Here you see, if we start from 1, then we have 3 neighbors, 2, this 3 and 4, right? So our aim will be to choose the neighbor which will have the minimum distance. So among 4, 3 and 1, we can see that 1 is the minimum distance. So we will choose this 3 as the next node. Now if any of the neighbor nodes are unvisited, find the node with minimum distance that we did, and we will add it to the cost variable. So as we will initialize the cost variable with 0, so after we found this node with the minimum distance, we will add 1 to the cost variable, and this will be considered the current node now. So we will recur for the found next nodes till a next node is found with 0 neighbors unvisited. So how will it be done? Suppose we are here, so we found out that 3 is the node with minimum distance, so we will mark it visited and add this 1 to cost. Now we are at 3. Now we will see we have 3 neighbors again, this 1, 2 and 4. 1 is visited, so we will not consider it. So among 2 and 4, we see that the distance are 2 and 5. So we will take the minimum distance, add it to the cost, so 1 plus 2, 3, and this node 3 will be marked visited. So now we are at node 2. Again 3 neighbors, 1, 3 and 4, but 1 and 3 both are visited, so we'll consider only 4. The distance is 1, so 1 plus 2 plus 1, it's 4. Now we are here. Now when we are at a node where we see that all the neighbors are visited, what we do, we simply take this node and we take the source node and calculate the distance between them and add it to the updated cost. So till now the cost was 1 plus 2 plus 1, 4, and now we will add 3, so 4 plus 3, 7, and that will be the answer for the traveling salesman program. So now let's jump on to the programming part and let's see how we can implement it. Okay, so here the first task for us is to take input the graph. So I'll use a function here and I'll name it take input. So let's first define this function. The return type will be void. Now before that, we'll need some global variables. So the first will be the cost, which will initialize with 0 value. Now we will need a adjacency matrix, so we will use a 4 by 4 2D array for that, and we'll use another array which is visited, which will again have only 4 elements. So basically we're trying to take the graph that we had shown you in the example. So now in the take input function, we'll first print the message to the user that give values. Then we'll be taking an int variable, the loop iterator, so now for I equals to 0, I less than 4, I plus plus. Inside this for loop we will need another variable, another for loop. So for j is equals to 0, j less than 4, j plus plus, will take the input. So scanf %d ampersand graph I j. That's it. So after doing this, we would like to see how the graph looks, so I'll just copy it. Now it will say the graph is, and it will say printf little tab, and outside the inner loop will print a line, right? So this is the take input function. So we have taken the graph. Now what we need is that we would like to initialize the visited array with all 0. So again another loop we will be taking. So I equals to 0, I less than 4, and I plus plus. What we will do is we'll take this visited array and make it 0. Now I'll take a variable which will be naming as start. It will give the start node value, right? So I'm going to take, before that I'm actually going to print a message for the user that enter start node. So now I'm going to use scanf %d ampersand start, and right here I'll be using a function tsp, and I'll pass this start node. So time to define the main function tsp. So it will again return nothing, so void, and it will, let's name it node. So what we will need first, we'll have to find the next node. So I'll take a variable next node. Now the starting node, this is, so every time we start with a node it will be marked visited. Okay, so what I'll do, I'll say visited of node will be 1. And this will also go down as the output. So print the node, this. Fine. Okay, here actually I can use another printf statement, tsp path. Yep. So now I'll need to find this next node. So for that I'll use a function find next node, and I'll pass this current node, right? So before defining that, what we will do, the logic is if we find the next node, then it's okay. Otherwise, how to denote that we have not find it? So it will actually return the node with the minimum distance. So I'll use this int max. For that, here I'll include a library limits.h. So now if this is the case, that this is the case when we will be reaching the last node, so the next node we have to visit is the starting node again. So what I'll do is I'll take a variable, I'll give it as value 0, I'll add to the cost the graph of next node and this v, print the message, basically the node only, so v. Okay, here this will be %d, and here this will be node, right? Again this will be %d v, and lastly we'll say return, so that after this nothing is done. So if this is not the case, then we'll recur for the newly found next node, that is next node, right? So now we'll define this find next node function. So basically this is going to return a node that is integer, and here we'll do something. So we'll be returning a node, so I'll take this, we'll be needing a minimum, and I'll assign it with a value of int max. Then we'll need a minimum index, and we'll need a demo cost, right? We'll basically also need a loop iterator, so for I is equals to 0, I less than 4, I plus plus. So for choosing the next node, we'll check few conditions. Conditions are if, first of all, the current node in iteration is not visited, so not visited I, and there is an edge between the node given and the current node, so graph of the node given to the current node is equals to 0, and also graph of the current node, that is the distance between the source node and the current node, is less than the minimum. Our aim is to find the minimum. So if this is satisfied, if all these conditions are satisfied, what we are basically going to do, we'll first add to the cost with this graph of node I, will update the min with this graph of node and I. Okay, sorry, this will be demo cost, right? And we will just assign it, and lastly the minimum index will be the I. So after the for loop, we will assign the minimum index, that is actually the node which will have this minimum minimum distance from the given node, and we'll add the cost for that to the cost variable. So we'll add the demo cost, and lastly we'll return the ND, the next destination kind of thing. So that's the function. Let's now test it and let's run it. So here is the output. Now we are going to take reference of this graph, so let's put value according to this. So this will be 0, 1, 2, 3, like that, the nodes of the graph. So first from 0 to 0 the distance is 0, then 4, then 1, then 3. Then here in this picture for node 2, 4, then 0, then 2, then 1. Then for node 3, 1, then this 2, then 0, then 5, and lastly for node 4, 3, then 1, then 5, and then 0. So now we will enter the start node as 0. So as we can see, the TSP path is 1, 3, 2, 4, 1, and the cost is 1 plus 2 plus 1, 4 plus 3, 7, as we had expected. So that was the simple way on how we could actually implement the Travelling Salesman program in C. Thank you for watching this video and staying with us. See you next time.